Yes, I'm Nilipour, and today I'll be talking about regularized maximum likelihood methods for black hole imaging, start building off some of the things that Paul Tita was talking about. Okay, Paul already gave us a really nice overview of very long baseline interferometry, but I want to recap really briefly how forward modeling approaches to radio interferometry work in the first place. So what we start off with is the image model, which is some estimates of the true sky brightness. And we forward model that, which involves taking the Fourier transform, applying, say, antenna gain corruptions and whatnot. From that, we get simulated observation products. And by comparing that to the true observation products, which are taken from observation, we form some likelihood function, which then informs our image model, and we iterate this over again to ideally optimize our image model to hopefully match the true sky brightness, to match the data. And what Comrade does, which is the package that Paul introduced, is do this in a Bayesian manner. So it forms some posterior from the likelihood function and priors on the image model, and then samples the posterior. But from a regularized maximum likelihood approach, or RML approach, instead we want to form a cost function, which is a data error term plus some regularizers. And these regularizers control for things in the image like smoothness or sparsity. And we can use the negative log likelihood as the data error term. And rather than sampling the posterior, what we want to do is minimize the cost function. And from these two equations, we see that they're really two sides of the same coin. We're just turning the prior function into these regularizers. And so with that in mind, what we've done is implemented RML in Julia as this VLBISkyRegularizers.jl. It's really just an extension of Comrade, adding regularizers instead of priors. And this QR code here, which we'll come on later, is a link to the documentation, which is not really yet complete. It has a single tutorial. And specifically what we've done is implemented a bunch of popular spatial regularizers. So this, for example, L1 norm, which regularizes for sparsity, or total variation and total square variation, which control for smoothness. We've also added a preliminary, still being tested, polarization regularizer, this PS distance, or Poincare sphere distance, which controls for smoothness and the polarization angle. And what the user can do in this package is compose regularizers in any linear manner. They can add regularizers or weight them by a scalar. It can also evaluate them in different domains, so either the linear or the log domain, where the log domain is often useful for increasing the dynamic range or the contrast of the image. And what Julia has enabled us to do, and which I'll talk about more later, is that the user can define custom regularizers. They're not limited to just these ones that we've already implemented ourselves. And I don't want to talk much about the package itself or the science behind it, but here's some sample imaging of some real data. So on the left is some published results from the M87 supermassive black hole from the 2018 data, which was just published last year, I believe. And specifically, I've chosen the two other RML packages that EHT collaboration uses, which are EHT imaging on the left, and that's a Python package, and Smiley on the right, which is a Fortran package. And that top row is the sort of raw fiducial results, and the bottom's the same thing but blurred to the nominal EHT spatial resolution. What I have on the right is our results from this Julia package. It ran super quickly. This is just that single tutorial on the GitHub, runs in a couple minutes. And we can see that we get results that agree with the published results, which is nice. Okay, for the last probably half of the talk, I want to talk more about the Julia side of things. And the first question is, why add RML functionality to Comrade in the first place, since Comrade is already a full Bayesian imaging software? And the most basic answer is that RML remains a popular choice for VLBI imaging, particularly within the EHT community. Yet these other packages, in particular EHT imaging in Python and Smiley and Fortran, are not nearly as fast or flexible as we would like. And that is sort of improved upon by this Julia implementation. And there was some discussion maybe back when we were starting this about maybe doing it in JAX or doing our own native Julia implementation without Comrade. But by adding it to Comrade, we're able to piggyback and use the likelihood function from Comrade as this data error term in RML. That just simplifies everything and puts it all together in one nice, larger infrastructure. And we all get all the other advantages of Comrade, such as hybrid modeling. So we can simultaneously fit a geometric model like a ring, a non-parametric image for small-scale flux, and a large-scale Gaussian maybe for the large-scale flux. And that's either complicated or impossible with these other RML packages. And also works well with other simultaneous developments for different Comrade extensions, which are ongoing. As Paul mentioned, there's some work to do stuff in the time domain, and Randy's now changed talk on multi-frequency synthesis as well. And some of the benefits of Julia I faced as a student coming from Python only for the past 6 or 7 years. I really enjoyed the multiple dispatch and type hierarchy, which not only enables easy integration with the rest of the Comrade ecosystem, but also simplifies the implementation of user customizable regularizers. So a user can just define a new sort of subtype of abstract regularizer, and everything sort of meshes well with the multiple dispatch, and just have to define what the function does, and that's all. Another huge thing is auto differentiation through Enzyme. Of course, that's one of the main factors behind Comrade speedup, and that applies to us as well, which makes us much faster than other comparable RML packages. It also eliminates the need for handwritten gradients, as Paul alluded to. These EHC imaging and Smiley use handwritten gradients, which, for example, for EHC imaging can look like this for something as simple as a total variation regularizer. And that's simply just not needed for the Julia implementation. All you have to do is specify AD type equals auto enzyme, and everything just works out. I'll also note here that Comrade previously also implemented Zygote as an AD backend, and we sometimes faced some errors with that when doing custom regularizers, but Enzyme seems to have gotten rid of all those issues, which has been really nice. And then some smaller things, I really like the convenience of Julia compared to Python. For vectorization and broadcasting, for example, you just add a period after your function, even if it's user-defined. There's also been this nice package I've been using, Tulio, which is an Einstein sum macro. And it takes something like this in Python. So the above is the total variation regularizer in Python, which is 15 lines of code, not terribly long, but a little bit cumbersome. And now it's just a single line of Julia code with this Tulio macro. And then just other macros in Julia that allow for really quick benchmarking and profiling that also nicely integrate with VS Code, which I've been enjoying. And then easy parallelization and multi-threading, which is pretty annoying in Python, but has really enabled me to use the full capabilities of my sort of 12-year-old PC. And yeah, so in summary, we've implemented RML methods in Julia as an extension of Comrade, and it's faster and more flexible than any other RML packages that are used by the Event Horizon Telescope, and that's all been enabled by Julia. And just overall, Julia offers many small and large-scale benefits in package development. And again, here's that QR code to the very bare bones documentation that will soon be filled out, hopefully. Thank you.
Questions?
Hi, you said it was implemented as an extension. So is it a separate package that you add, or is it just is it loaded in as a package extension when you load something else?
It's a separate package.
Okay.
So yeah, a little bit complicated, but not too bad with Julia's package manager.
All righty, let's thank Andy again.